So here's a third example, and then again, it'll be a little different than the other two. So let's, we have x to the fourth minus x cubed plus 2x squared minus 4x minus 8. I think I'll put that in the calculator. I know that I should have 4 zeros because it's an x to the 4 function, but let's just take a look at it to make sure we don't need to scale this thing differently. So I have x to the fourth minus x cubed plus 2x squared minus 4x minus 8. Let me hit graph. I know I should have 4 zeros. And let's see what happens here. Let's see if we see some that we can use to graph. All right, this one's an interesting one. I see that I have a 0 at -1 and a 0 at 2. I know I should have 4 zeros, but all I see are 2 real zeros, so it makes me wonder if, since I can't see the others, if they're way out here on the sides, or if maybe they're imaginary. So before I graph, I'm going to go try synthetic division with the zeros I see. And I see -1 and 2. So I'm going to try -1 first. So 1, -1, 2, -4, and -8. So I bring down the 1, multiply, add, multiply, add, and multiply. So yes, -1 is a 0. Let's try the other one we see. It looks like it's at 2. I can verify that by looking at the table. So multiply, multiply. So yes, 2 is a 0. So this was x to the fourth, this was x to the third. So what I have is x squared plus 0x plus 4 equals 0 to find the other zeros. So if I solve this one, I get x squared equals -4, square root both sides, so x equals plus or minus 2i. So this means that I can't see the other 2 zeros because they are imaginary. So I can go ahead and graph the ones that I see. So I saw -1, and I saw +2, and this is x to the fourth, so I know the end behavior should go up here and up here. So that means then that since both ends are going to infinity in the positive direction, this has just got to kind of swoop down here and come back up. So let's go ahead and write in our end behaviors. This one, the f of x is the same, so I can write it as one statement. As x approaches positive and negative infinity, the end is always approaching infinity. So it doesn't look like there's going to be a local maximum because it never happens here. It just goes down and dips. So let's find that minimum value. So I'm going to push second trace, which makes it calculate, and I need a minimum. But left bound, it looks like it's already there for me. So I'm going to hit enter, and then I'm going to arrow over until I get on the right side. Doesn't look like it's too far down there. And so I don't want to guess, but then it tells me that the minimum is at 0.88. By the way, if your number is off from mine just slightly, that's fine. And -10.05. So we may be off a tenth or a hundredth, and that's okay. So I'm going to go over to 0.8 and down to -10. 0.05 should be about right in here. So there would be my local minimum, or my turning point, as some teachers might call it, and the graph would look something like this. Let's go ahead and do this last one on the same video. I think you'll find it's pretty easy. It basically already has this factored for me, so I don't have to do the synthetic division. So I have an intercept at -4, an intercept at 3, and I have an intercept at -1 with multiplicity 2. It happens twice. So let's put those in here. -1, -4, and positive 3. So since multiplicity -1 happens twice, I know that's going to be a turning point. So this is going to be of x to the 4th equation, and this is a positive integer, so the n's are going to go up like this. So my n behavior as x approaches positive and negative infinity, f of x approaches infinity. Now I know that multiplicity 1 means it's going to be a turning point, so that means this is going to go down. It's going to go up to -1, but since it happened twice, that's a turning point. Then it's going to go down, turn, and come back up. So I do have a local maximum right here at -1, 0. Now I just have to find my minimums, and this time there are 2 of them. So we don't have to multiply this out. We can put it in the calculator just like it reads. So I'm going to hit clear here so I can type in a new one. So I'm going to do parenthesis 1/12 parenthesis x plus 4 parenthesis x minus 3 parenthesis x plus 1 parenthesis squared. So then I'm going to graph it. The graph should look pretty similar to what we've got there. The ends should both be going up. We should have a turning point at -1, and then it should go back up again. So we just need to find these 2 minimum values right here. So I'm going to hit second, calculate. I want the minimum. So I'm going to get over here on the left side of this first little dip and hit enter. And then I'm going to go get on the right bound and hit enter. And then, so I have one minimum at -3.1, -2.01. Okay, let's go find the other one. So second calculate, minimum, and then I want to go over here on the left side of this other one and hit enter, and then go get on the right side and hit enter. I don't want to guess, so I'm going to hit enter again, and the calculator says the other one is at 1.8, -4.5. So I'm going to go plot those. This one's at -3.1, down -2. It kind of turns right here. The other one's at 1.8, down -4.5. And it goes something like this. If you're having any trouble with your calculator, come in. I'll be glad to help you.